In this video, we are going to learn how to translate among tables, graphs, equations, and contexts of proportional relationships. So basically, we're really putting together everything we've learned with proportional relationships and going between all of them. This is the format that we're going to use to show the 5 representations of the proportional relationship. Basically with the 5 reps, which I'm going to call it 5 reps for short, basically with the 5 reps, what we are looking at is that we are going to be given one of the representations. So it could be the table, the context, the equation, the graph, and the language. And from having just one of them, we should be able to figure out the other 4. So on this one, we have the context. You should also have the recording sheet that has the same things as I do. So as I am going through these, you should be filling it out on your recording sheet as well so that you can see how this is done. You can always pause the video if I'm going too fast to catch up if you're having trouble keeping up writing things down. So on this one, we have the context. It says that the tax on pop is 3 cents per ounce. So with the proportional relationship, we've talked about how the unit rate shows up in the proportional relationship. And in this case, it's the 3 cents per ounce. That's our unit rate, cents per ounce, 3 cents per ounce. Now, I can go and make the table, the equation, the graph, the language based on that context. It really doesn't matter which one you start with. Sometimes it's easier to start with one versus another, but there's really no right or wrong answer. I'm going to start with the equation this time. Since I know that 3 is my unit rate, remember in our equation, the equation format is y equals the unit rate, which is 3, times x. Y equals 3x. So I've got my equation done. Then I usually like to go to the table before I make the graph. That's just what I like to do. So I'm going to say that my x is going to be my ounce. I just like to label it so I know what I'm talking about. And then the y is the tax. So if I would have 0 ounces of pop, then I'd have 0 amount of tax, which is in a proportional relationship. Remember, it always starts at 0, 0, or it goes through the origin. If I have 1 ounce, I'd have 3 cents. 2 ounces would be 6, 3 ounces would be 9, and 4 ounces would be 12. So I can really choose whatever numbers I want to put into the table. I usually just go kind of easy numbers, start with 0. Usually I go up by ones, depending on what makes sense. In this case, I think it makes sense just to go up by ones. Then I'm going to go to the graph. The graph, I can see if this is my x is my ounces. And then if I know this is my y-axis, that's going to be my amount of tax. So labeling the ounces, I know from my table I go from 0 to 4. So 0 is going to start here. And I have plenty of space on the bottom. So I think what I'm going to do is I'm going to go every other line just to space it out a little bit. So every other line, then I can use the whole graph. You always want to space it out as much as you can. And then for tax, I need to get up to 12. So if I count by ones, I'm not going to get quite up there. So I think I'm going to have to go by 2. So I go 2, 4, 6, 8, 10, 12. And now I'm just going to plot the points. Having the table helps me so I can just plot the points. So I'd have a 0, 0. I'd have a 1. 3 is going to be halfway between 2 and 4. 2 is going to 6. 3, 9 will be halfway between 8 and 10. And then 4 is up at 12. And you can see this graph that I just made. I'm going to connect it with a straight line, kind of. It goes to the origin. It should be a straight line, which is what we talked about with the proportional relationships. Now the language is really just a sentence describing this proportional relationship. So you're always going to use this format. It will be, this is a proportional relationship with a unit rate of 3. So really the only thing that changes in that language will be the number. So in this case, we have a unit rate of 3. So next time if you have a different unit rate, that sentence is exactly the same except the 3 changes. And that is how you make a 5 reps. On this next one, we are given the table. So you can see we have hours and miles. And our table here goes 0, and then it goes 2, 4, 6, 8. So remember, if we're looking for our unit rate, we talked about how we can take the, oops, I gotta get the pen on here, take the y divided by the x. So if I look at that, it'd be like 4 divided by 2, or any of the y's, 16 divided by 8. See how for each of these, no matter what I do, I'm gonna get the same unit rate, which is 2. So then for the equation, I can jump there. My equation is going to be y equals 2x. Now, oh, that y is a little weird. If you think about the table in the context has to be something that is going up by 2 each time. We're kind of given a context because we're told that there's hours and miles. So whatever we're talking about, it has to say something about hours and miles. So it could be something that for every hour, you're going 2 miles. So maybe the context could be, it could say something like, Susie walked 2 miles per hour on her hike. Something like that. Could be anything about someone walking or traveling 2 miles per hour. Since our unit rate was 2, we know that it's going to be 2 miles per hour. Then I'm going to go down to my graph. I know that for my hours, my table has from 0 to 8, and that's my x, so I'm going to put that down here. And I'm just going to go by ones so that I can fit all the way up to 8. And then I'll have my miles here on the y, and I'm going to go up to 16. So once again, I can't go by ones, otherwise it's not going to fit. So I'm going to go by 2s on the y. Keep in mind you're doing this along with me on your paper. Pause if I go too fast and you're still working on it. And then I'm just going to plot my points. So I'd have 0, 0 down here at the origin. Then I'd have 2, 4 right there, 4, 8 right there, 6, 12 right there, and then 8, 16 here. And then you can see my proportional relationship goes to the origin. It's linear, it's a straight line. And then finally, my language, remember it's the exact same sentence every time. This is a proportional is quite a long word, relationship with a unit rate of 2 this time. So the only thing that changed was what the unit rate was. This time it's 2. So this time we're given the graph. We haven't done a lot of work with the graphs and figuring out the equation from it. So for this one, let's handle this by just looking for some points. I can see that that would be a nice point to use right here. See these points that I could use, and I'm going to put those into the table. So this first one is going to be 0, 0. This point here, if this is a 4 right here, this would have to be a 2. It means it's going up by 2s. So that would be 220. Then I'd have the 4, 40. This point right here, that would have to be a 6 there, so 660. And then this last point right here is going to be 880. Now, same deal, if I want to look for that unit rate, I'm going to take the y divided by the x. So I could take any of the y's. 40 divided by 4, 60 divided by 6. Every time I do that, I get 10 when I take y divided by x. So that's my unit rate. So I'd have y equals 10x. Now, let's talk about the context. Sometimes kids have trouble figuring out context. We just need to think about something that grows by 10. A lot of times you can think about money, like it could be earning $10 per hour. It could be gaining 10 things every day. So it could be that you, it could be earning money. It could be that you are gaining 10 in temperature. It could be that you are saving $10. It doesn't always have to be money. It could be things. It could be that you are having it could be that, I don't know, it could be food. It could be something with like you're eating, every kid is eating 10 cookies or pieces of candy. So for this one, maybe I'll just keep it simple and I'll say that Mark earned $10 for each lawn he mowed. Could be anything like that. And then for the language, same sentence. Remember, this is a proportional relationship with a unit rate of 10. This time we're given the equation, so y equals half x. Now, if you're given a fraction like we have here, you can keep it as a fraction and use it for half. Use it as half, or I could always change it to a decimal, so it could also be thought of as y equals 0.5x. Kind of depends on your context sometimes. A lot of times I'll change it to 0.5 or 0.50 if I'm dealing with money, so it would look like 50 cents. I think it makes more sense to put it as a decimal, or I can use it as the fraction. So like maybe I was talking about recipe, because a lot of times you have fractions in that. So maybe a context for this could be the recipe called for half cup chocolate chips, because I like chocolate, per batch, like batch of cookies or batch of bars or something. So then if I go over here, I'd have my x is going to be the number of batches, and then my y is going to be the cups of chocolate chips. So if I make 0 batches, I need 0 cups. If I make 1 batch, I need half a cup. 2 batches, I need 1 cup. 3 batches, I need 1.5 cups. And 4 batches, I would need 2 cups. So then if I go down to my graph, I would have the batches down here. And I just went up by ones, so I don't have to get very far. I think I will skip a line though, just to space it out. So 0, 1, 2, 3, 4. And then the cups will go on the y-axis. And I don't have to get up very high because it is only going to 2. So I might actually skip quite a few. I might go and say this is half right here, and then this is 1, and then this is 1.5. So I'm actually going by fourths if you think about it, and this is 2. And then plot your points. I have 0, 0. I have 1 half. I have 2, 1, 3, 1.5, and 4, 2. And once again, it looks like a proportional relationship. It goes through the origin, and it is a straight line. And then finally, my sentence. I usually save this for the last one for some reason. Oopsies. I wanted to erase that because I need to write this is a proportional relationship. Proportional relationship with a unit rate of half. And that is another 5 reps. So hopefully at this point you feel like if you're given any of these 5 representations, you can figure out the other 4 and be able to translate between tables, contexts, equations, the language, and the graph. So make sure you have your recording sheet done, and let me know if you have any questions.